In this video, we are going to be taking a look at area and mixed numbers. And the essential question that we are going to try to answer throughout the video is how can you use a unit tile to find the area of a rectangle with fractional side lengths. So I want you to turn to page 317 and we're going to investigate this problem together. And we can see at the top it does say you can use square tiles with side lengths that are unit fractions to find the area of a rectangle. Okay, so the problem reads, Sonia wants to cover the rectangular floor of her closet with tile. The floor is 2.5 feet by 3.5 feet. She wants to use the fewest tiles possible and does not want to cut any tiles. Probably wants to use the fewest tiles because that's the cheapest, and does not want to cut any tiles because that could be extremely difficult if you do not know what you're doing. So the tiles come in three sizes: 1 foot by 1 foot, 1.5 foot by 1.5 foot, 1/4 foot by 1/4 foot. Choose the tile that Sonia should use. What is the area of the closet floor? Okay, so what we will need to do is think through which square tile Sonia should choose. Now, if we're taking a look at some things that we know, the floor is 2.5 feet by 3.5 feet, so she wants to use the fewest tiles possible and does not want to cut any tiles. Now we know right away if we're doing one foot by 1 foot square tiles, we know that the tiles will not cover the whole floor and would extend past the floor. So even though it would cover it if we used all of them, remember she does not want to cut any tiles. Now if we're taking a look at the 1/4 by 1/4, okay, now that would work actually, but we need to remember that Sonia wants to use the fewest tiles possible. Okay, because we know that 1/4 definitely could be added together to get to 2, and then also to 2.5. 1/4 could be added together to get to 3, and also 3.5. However, fewest tiles possible. Okay, so which tile should Sonia choose? It's going to be 1.5 foot by 1.5 foot. And let's write this explanation down. I'll have it for you here. Okay, here's the answer that I do want you to copy down. The 1 foot by 1 foot would be the answer. 1.5 foot by 1.5 foot would be the answer. The 1 foot by 1 foot square tiles would not cover the whole floor or would extend past the floor. However, the 1/4 foot by 1/4 foot square tiles would fit, but remember they're not the largest and would not be the fewest tiles. Okay, now we have a grid that we're going to look at for section B. It says on the grid, let each square represent the dimensions of the 1.5 foot by 1.5 foot tile that you chose, then draw a diagram for the floor. So each square here represents a tile. So remember the closet is 2.5 feet by 3.5 feet. Okay, so what we will do is, remember this is 1/2, this is 1, 1.5, 2, 2.5, 3, and then 3.5. Okay, now we need to go down 2.5 sections. Okay, or I'm sorry, we need to go down representing 2.5, and remember each square does represent a half. Okay, so this is 1/2, 1, 1.5, 2, and then 2.5. Okay, now we don't have to count this nearly as carefully because we can just match it up with the other side. I'm trying to draw the straightest line as possible. Maybe Mrs. Hardy can help me out with my drawings. Okay, there we go. So what we can do is we can count the squares in our diagram. So we have our diagram now. All right, now we can see that we have 1, 2, 3, 4, 5 squares going down. 5 total squares going down, and then 1, 2, 3, 4, 5, 6, 7 going across, or a total, if we were to multiply 5 times 7, that would give us the area where we could count up 35 total squares. Now what we need to do is find the area of the tile that we chose. Now I know it's 1.5 foot by 1.5 foot, but we need to find the area that this represents. So what we need to do is take 1/2 and multiply that by 1/2, and that is actually going to equal, yep, you got it, 1/4. Okay, so the area of the tile that we chose is 1/4 square foot. Let's write that down. So since 1 square on our diagram represents an area of 1/4 square foot, the area represented by the 35 squares is 35 times 1/4, or, as we can see, will give us 35/4 square feet. Okay, so the area of the floor written as a mixed number is actually 8 3/4, because we multiply the numerator by the numerator. That gives us 35, and the denominator stays the same, giving us 4, for a grand total of 8 3/4. Okay, now let's turn to page 318, and we'll take a look at this problem. It says use an area model to solve 1 3/5 times 2 3/4, and this is under the making connections section. Okay, so step 1 for this is we need to rewrite each mixed number as the sum of a whole number and a fraction. Okay, so what we have here is we have 1 plus 3/5 will give us 1 3/5. And the next one will be 2 plus 3/4 for 2 3/4. Now step number 2, what we want to do is draw an area model to show the original multiplication problem. Okay, and I have my rectangle written just like this. I want you to draw a rectangle as well right in your book. Okay, we want to label it 1 3/5. And then the top part 2 3/4. Okay, so we have 1 3/5 and 2 3/4. Now what we need to do for step 3 is we need to draw dashed lines and label each section to show how you broke apart the mixed number in step 1. So remember, step 1 we had 1 plus 3/5 and also 2 plus 3/4. And we'll look at this together. Now what we will need to do is really break down that fraction. Okay, so what we will have here is we're going to have 2 right here, and then plus, we're going to do 3/4 on off to the right. Okay, so what we will have here, this is going to represent, just make a line, do the best you can with your lines there. Okay, so that can represent that, and then we're going to need a section representing 2. Okay, and then also we're going to have 1 3/5, just like that. Okay, so we're going to have the height of 1, the length of 2. Okay, and we can go all the way down just like this. Alright, now what we have here, you can see that this space right here would be 1 times 2, and that's going to give us 2. Okay, now for this section here, this represents 3/4 lengths. The height is going to be 1, so we have 1 times 3/4, and that's going to give us 3/4. Just like that. You can follow along with me as I do this, and we'll do this together. We have 3/5 height, length, you can see right here, look at the 2, times 2. That's going to give me 6/5. And then finally, we have 3/5 height, 3/4 lengths. So we take 3/5 times 3/4. That's going to give us 9/20. Okay, now what we do is add all of our answers together. Okay, all of our products. So what we have is we have 2 plus 3/4 plus 6/5 plus 9/20. Okay, and what that will give us is 88/20, or 4 2/5 when we simplify that. Okay, so we could say now the product of 1 3/5 times 2 3/4 is 4 2/5. Okay, now we're going to look at this grid, and each square is going to represent 1/3 by 1/3 meter. Okay, so we have 1 2/3, so let's draw that out. This is 1/3, 2/3, 3/3, or 1 whole. 1 1/3, 1 2/3. Okay, moving down, 1/3, 2/3, 3/3, and then finally 4/3, or 1 1/3. We can connect this section now. All right, so we have a diagram to represent the dimensions, and we can see that this is 1 2 3 4 by 1 2 3 4 5, so 20 squares. Now, something that we need to remember, the area of each square, if it's 1/3 by 1/3, what we do is we multiply 1/3 by 1/3, and that is actually 1/9. Okay, each square actually represents 1/9 of a square meter. Okay, and the area of the diagram, what we do is we take 20 and we multiply that by 1/9. So we take 20 times 1/9, multiply numerator by numerator, move the denominator over, 20/9, which could be broken down to, or simplified to, 2 2/9 square meters. Okay, I want you to work this problem out all by yourself. When you're finished, you can press play and I'll have the answer for you. So pause the video now. Okay, I have the answer for this problem for you. 2 5/8. Check my work and make sure it matches yours. Let's move on to the next problem. Okay, I want you to work this problem out all by yourself. When you're finished, you can press play. Pause the video now. Okay, here's the answer, 1 7/8 square feet. Check my work, make sure it matches yours. If you have a couple questions about this, you may need to rewind the video. Now, I do want you to use an area model to solve this problem right in your book, and when you press play, I will have the answer for you. Okay, now however you did your model, I don't have one for you because it could look a couple different ways. All right, so what you should have had was 1 1/9 times 1 2/3 gives you 1 23/27. Okay, I do want you to do this test prep problem. Try to say that 3 times fast. And when you're finished, you can press play and I will have the answer for you. So I want you to pause the video now. Okay, the answer for your problem should be letter A. Make sure you have the correct answer. And as we wrap up this video, we are going to take a look at the essential question, which is how can you use a unit tile to find the area of a rectangle with fractional side parts? What you can do is cover the rectangle with fractional unit tiles and then multiply the number of tiles by the area of each tile to find the total area. So this concludes the video on area and mixed numbers. If you have any questions about this concept, please come and see me.